In this video, I'm going to demonstrate the operation of the pneumatic squeeze riveter for dimpling aluminum sheet for your dimpling project. First, you need to get yourself a couple test strips, same material and thickness as the project you're going to be using. You want to space out the holes the same spacing as your project. Then go to your instructor and get yourself a set of these dimple dies. Set up the pneumatic squeezer into a vise. Make sure it's secure so it's not going to fall out. Then you'll want to get your dimple dies. Select the correct size according to the hole sizes that you've drilled. In this example, we've drilled 1/8 inch holes, so I'll use the 1/8 inch diameter dimple dies. So you can just stick your dimple die through the hole and see that it does fit nice and snug. I'll check the surface of my dimple die for any foreign tape or whatever glue on there. Make sure nothing is on there that doesn't need to be on there and that there's no damage to it. And I'll check the female die in much the same manner. Also check down inside the hole of the female die. If there is any swarf or masking tape in the female die, you can remove that by using a drill bit one size smaller. There, see, I pull that a little bit out there. So these two pieces should fit together nice and smooth, and you can just rotate them in your fingers and you'll see that they have a beautiful mating surface. So I will begin by inserting these dimple dies into the pneumatic squeezer. I like to put the male die on the side of the squeezer that is not moving, and I put the female die on this side here. That's my own preference. At all times when you're working in this area here, installing or removing the dies, you want to make sure that your air line has been disconnected. This pneumatic squeezer can, when you pull the trigger, can produce a pressure of up to 5,000 pounds per square inch, which would definitely squish your fingers and anything else in there. So I like you to pull the trigger just a few times, get a feel for the machine so you're not surprised the first time you pull it. So we'll just go ahead and pull it and see how it closes quite nicely. And I like to play with the trigger and get it the squeezer kind of to dance there. I call it dancing. Just moving it back and forth gives you a good feel for the trigger, so you're not surprised when you pull it for the first time. So then we'll grab our test strips, and at this time you want to stick a cleco into them to make sure they're held securely together. So here I've inserted a cleco, and I'm going to use the side that I've marked up against the male die. You can hold it yourself or get your partner to hold it, the test strip for you, and go ahead and squeeze it on down. Now you'll see that the squeezers don't come together at all. There's a fair big gap in there. So you can release that, and you'll see that you'll need to have to place some shims under the back side of these rivet dies. So unplug the air, pull out the male die, and I'm going to insert I have both thick washers and thin washers that I'm going to use for shimming on the back side of the rivet die. Now you want to make sure that using a thick washer on the back of each die balances out the washer stack up evenly from the female die and the male die. So I'm going to grab a thick washer and place it on this side of the die and place it back in. Pull out the female die. Take a thick washer and place it on the back side of the die and reinstall the dies. Plug the air back in, and you can squeeze it again without the test coupon in there just to make sure they do come together nice and smooth. And you'll see there's a gap in there and they're free to rotate. That means that they haven't touched each other yet. There's a slight gap in there. We're not sure if it's big enough or small enough yet. Remember, you cannot dimple too deep. you can only dimple too shallow. Once these two dies have fully come together, all you can do is increase the dimpling pressure or reduce the dimpling pressure. And that will be apparent by the test strip either taking a concave or a convex form. So I'll place my test coupon back into the over the male die and give it a squeeze and see what happens. Okay, you can see in this one here that it seemed to come down fairly good on the very first try. There is a slight burnishing mark on the surface of the L-clad due to the dimpling pressure. And if we want to eliminate that, and it's nice to eliminate that if we can, it's not doing any damage to the sheet, but it is nice to eliminate that, then we can get some protective plastic material from the aluminum that is used for shipping to protect it while in shipping. You can use some of this stuff here. There's the clear stuff, which is fine. I like to use the blue stuff. I don't know why. It's just a little different material than the clear stuff. The clear stuff will work. And in this example here, I've got a hole already drilled into the aluminum, because you'll find many bits in the scrap bin with a number 30 or a 1/8 inch hole in them, which will work fine. Take off the plastic strip. You want to make sure that it has no aluminum swarf on it. It's nice clean. It's got a nice clean hole, no excess plastic. And I'm going to place it here over top of the male die, lining the hole up, fold it back. Now the surface is well covered and protected. And I'm going to use a piece of masking tape to hold back this thing just so it doesn't fall off as I'm dimpling. So that'll hold it temporarily there while I'm doing the dimpling process. So I'll take my test strip, and now I can place it over the second hole, and I'll give it a little squeeze. And as you can see now on this one here, the burnishing mark has disappeared. If you look at the side of the strip, you'll see there's a slight bit of concave that is happening here, meaning that I probably can increase the dimpling pressure slightly. So at this time, I think I'll disconnect my airline, pull off the female die, and I'll install a thin washer in behind. So I'm going to install a thin washer in behind the thick washer. And this will increase my dimpling pressure. Place it back in the machine, reconnect my airline, and now I can dimple back the very first one I did. I can redimple that one again, no problem. And then I'll dimple the second one that I did. Make sure to keep your hands clear. And you can see here now that the sheet is actually flattening out. If the sheet were to start going convex, bending away from the dimple, then I would have too much dimpling pressure, and I'd have to remove that washer that I just installed. So I've got two dimples in here. I'm going to take my Cleco and transfer it across to the first hole. And I'm going to do the other two, the last two. That one looked out like it worked here well. And this one worked well. So we've dimpled a test coupon, pneumatic dimpler, and we can test the flushness of the dimples we just made by installing a couple of rivets into the holes and using a straight edge or another piece of aluminum, placing it across the rivet heads, holding it up to a light and checking for a gap. And as we can see, this one here is fairly flat. If there is a slight warp in it because of the way the dimpling process went, you just work that warp out with your fingers. Aluminum is quite soft, easy to work, so just work that warp out with your fingers. You want to make sure that you have both sheets with no warp in them before you rivet it together. That works the best. And that's all there is to dimpling using a pneumatic squeeze riveter.